All right, everybody. So I have made two videos regarding what the definite integral is and some methods for evaluating it. And now in this video, I'll focus just on one application, one use of a definite integral, which is to calculate or measure the area on a graph. Okay. So I'm going to explain to you two scenarios for using the definite integral to calculate area. All right. And when I say area, this is what I mean. Sometimes I might forget that really simple things can be elusive. So let's say like here's a rectangle. And this is not the scale. Obviously, I'm just drawing this real quick. And let's say this is 1 foot this way. And let's say this is 2 feet this way. Not to scale, but just so you get the idea. Then I can tell you that the size of this, which the area is the measure of the size of a plane or flat figure. The area of this is 2 square feet. Okay. And we say square feet because what we're saying is that if you had a 1 by 1 square, 1 foot by 1 foot square, you could fit exactly two of them in here. So that's how big it is. So that's why area units will always be square this or square that, square feet, square centimeters, square inches. You get the idea. Okay, so in this video, when I say that a definite integral will calculate the area of something, this is what I mean. It means like if measurements were involved, if on my graph I had units, maybe like every mark was a centimeter or a millimeter or something like that, then the definite integral's area calculation is going to be in square units of some kind. It's going to tell me how big the space that I'm referring to is in square units. Okay, so here are the two scenarios for area in the definite integral. So in either scenario, we have a curve, we have a graph. Okay, so this refers specifically to graphs. Here I have the y-axis and the x-axis, and in this other one I have the y-axis and the x-axis. I have a curve of some kind, y equals f of x, y equals f of x. And what divides these scenarios apart is that here the curve is above the x-axis from number A over to number B on the x-axis. Okay, and in this one, the curve is below the x-axis from number A to number B on the x-axis. So we'll have to look at it where we're trying to find the area from number A to number B, and then the curve is either above the x-axis or below the x-axis, at least from number A to number B are concerned. What happens outside of number A and number B doesn't have any relevance to what we're doing. Okay, now say you want to know the size of this thing here I have shaded in red. It's the area above the x-axis and under the curve from number A to number B. You can calculate that straight away by this definite integral. Okay, so I've made some videos already about how you evaluate a definite integral. So if you set this up, lower bound A, upper bound B, that function is the equation for this curve. You evaluate that, the number you get will be a measurement of the size of this region. It'll tell you how big it is in square units, like whatever the units are. Okay. Now, in this other scenario where the curve is under the x-axis, the curve, like every point on here is a negative number, at least the y-coordinate is, then the area here, shaded in red, above the curve and under the x-axis from number A to number B, can be calculated as the opposite of this definite integral. Okay, so the integral goes number A at lower bound, number B upper bound. F of x is the equation for this curve. Okay, you evaluate that, you'll get some negative number. You take the opposite of it, you take the negative away. That number will be a measurement of the size of this region, the area. Okay, so those are the two scenarios. Let's look at an example of each one of them. Okay, so here's an example where we have the curve f of x is equal to x squared plus 1. It looks like this. It's a parabola. And let's say I present you with the area under that curve and above the x-axis from 1 to 2. Now my graph here is not perfectly to scale, it's just for illustration purposes, but this curve is in fact above the x-axis from 1 to 2, all right? So to calculate this area, we would just have to evaluate this definite integral straight away. It's like I showed you on that first slide, right? The definite integral with from 1 to 2 x squared plus 1. So remember, how do we evaluate definite integrals? Well, we find the antiderivative of this function right here. In our case, that's x to the third power over 3 plus x. I put in my upper bound first. That's how you get the 8/3 and the 2. I subtract. I put the lower bound in second. That's how you get the 1/3 and the 1. And then I work this out. It's a matter of arithmetic at that point. This turns out to be 10/3. Okay. Now on MyMathLab, it might be that you're asked to round your answer sometimes. Like it might say give a fraction. 10/3 is a fraction. It might say to round your answer to 1, 2, 3 decimal places. Who knows? Well, that would be 3.3 to round to 1 decimal place. Okay. So 10/3 square units. 3.3 square units. If you had a 1 by 1 square, you know how many of them you could fit in here? A little more than 3.3, okay? We'd have to have units consistent with however you're measuring the 1 and the 2 and so on. But that's what we mean by area. All right, so that's what we do if we want to find the area under the curve when the curve is above the x-axis. What about this one here? I've got this curve. I call it a curve. It's actually a straight line. F of x equals negative x minus 1. It goes like this. It's under the x-axis if you graph it, okay? And I'm curious, can we find the area from 1 to 3? So above the curve, below the x-axis from 1 to 3. How would we do that? Well, remember up here, if the curve is under the x-axis, we will just evaluate the definite integral from a to b. We'll get a negative number when we do that, and we'll take the opposite of it, and that number will be the area. Okay, so here I set up the definite integral from 1 to 3, negative x minus 1. Okay, I'll evaluate this definite integral the same way I would any of the problems I'll show you in this class with the antiderivative. There it is. I put in 3. That's how I get negative 9 over 2 minus 3. I subtract. I put in 1. I get negative 1 over 2 minus 1. And then I do the arithmetic. That turns out to be negative 6. Okay? All right. So the area, the size is not negative 6. It's 6, right? You take the opposite of that. So the area is 6. And I'm going to put square units. Okay? Because I want to emphasize to you that this is a measurement. You know, it's like I'm saying if all my marks on my graph were in inches, okay, and I had this to scale and everything, it'd be 6 square inches. That's how big this is. 6 1 by 1 squares would fit inside of it. That's how its size, that's its area. Okay, so my final answer there, after I take the opposite, 6 square units, that's the area. Okay, now let's look at one that is on the MyMathLab assignment that I have in mind for this video. I want to show you a graph on MyMathLab real quick. So this is a problem from assignment 4.2, at least as I'm making the video right now. And it says find the total area of the shaded regions. Okay, so I see there's this graph here. Let's zoom in a little bit. It says f of x equals 9 minus x squared. And I see in some parts of this picture, the graph is above the x-axis, and in other parts, it's below the x-axis. And I'm supposed to find out the total area that's shaded. So that would be like this, that'd be all of this, and that'd be all of this. Okay. So it looks like I'm going to have to, based on the principles I showed you already, based on the fact that how you measure the area with respect to a curve and the x-axis, whether it's under the curve or above it. Depends on whether the curve is above or below the x-axis. Okay, so here's what I'm going to do. So with this graph in mind, let me see if I'll get this picture up here. Okay, so I have the integral from 0 to 3, 9 minus x squared dx, and I'm saying double this. So here I'm using symmetry. So you see how the part of this picture where the curve is above the x-axis actually goes from -3 to 3. But notice this curve is a mirror image of itself along the x-axis. So I can take advantage of that. I can find the area from 0, right here in the middle, to 3, which is where it crosses over. And then I can double it, and that will be all of this space on top. That'll be the size of all of that space on top. So that's why I'm saying do 0 to 3 and double it, okay? You could do, if you want to, if you're curious, you could do -3 to 3 and not double it. But it turns out that 0 is a very easy number to work with. And so I'm going to take advantage of the fact that I can use 0. Okay. Now that turns out to be 18, and I'll need to double that. All right. 18 is the area from 0 to 3. So all of this space would be 36. All right. Okay. Now what about these regions down here? Notice how they're the same too. This one goes from 3 to 4. This one goes from -3 to -4. But they're identical. Again, this graph is a mirror image of itself across the y-axis. So I could calculate the area of this little piece, which is from 3 to 4, and double it, and I would get the combined size of this piece and this piece. Okay, so I'm going to do that. So I'm going to take the opposite of this one, and I'm going to double it. I'm going to take the opposite because from 3 to 4, that curve is under the x-axis. And so that's what we do when we're using a definite integral to find the area when it's underneath, right? So I do two things. I'm going to take the opposite of whatever I get from this, and I'm going to double it, okay? Now, I work this out as I would work any indefinite integral, and I get -10/3. Okay, so here goes. There's my setup. I'm going to make sure you understand the rationale behind the setup. Okay, all right. So I'm going to give my answer like this. The total area is going to be, I got to double this because that was only half of the picture that was above the x-axis. And I got to combine that to get all of it. The opposite of this also doubled. Okay, so I'll get 36, 2 times 18, plus 20 over 3. And let's look at how MyMathLab wants us to put the answer in. It says type an integer or a simplified fraction. Okay, so I'll work this out by hand. I don't think it's a bad idea to know how to do some math on paper. I know that you would probably put it in your calculator, but if I was going to put these in terms of 3, get a common denominator of 3, this would be 108 over 3 plus 20 over 3. So I get 128 over 3 square units. That's how big it is. All space accounted for. Okay. All right, let's put that in. I followed those instructions right there. All right. So let's see, what did I get? 128 over 3. Okay. I'm going to check it, and it's correct. All right. Now, so that's how we can handle something like this. We'll break it into parts depending on which parts of the picture are above the x-axis and which parts are below. Now, on some of the other questions, notice this one, some of it's below, some of it's above, same consideration. I'll work this one out, and I'll work this one out. I'll take the opposite of whatever I get there, and then I'll add them together, right? And then this one, notice that it doesn't have a picture with it. Now, some of you have graphing calculators. Some of you might use some online graphing tool. I don't think there's anything I can say that would apply to everybody, because you might all use different things. But let's say that you would need the graph, or at the very least you'd need to know where the graph crossed over. See, I would have to draw this somehow, or see it from -1 to 6. At the very least, I'd have to know where it crosses over, because those points where it crosses the x-axis is going to divide up where it's above and where it's below. And as you know, the way that we handle the integrals to measure the area is different if the curve is above or below. Okay, all right, so I'll set you loose with it. That should be enough for you to attempt the assignments. If you need a little bit more guidance on graphing, such as you're not sure how to approach getting some initial picture to work something like this, you can always let me know. I can make more videos. I can help you. All you have to do is ask.